Now imagine this: if you were sent 3,000 light years away from our world to another planet, and from there you observed Earth using an equally powerful telescope, do you know what you would see? Astonishingly, you would see Earth as it was 3,000 years ago, that era when ancient civilizations flourished. This means such a powerful telescope would work like a time machine for you. Of course, you would not be able to physically travel to Earth's past, but you would certainly be able to see it. Now step out of your imagination and look at this machine, because this is the telescope that had the ability to observe stars and planets located millions of light years away from our world. After 30 years of hard work, it has finally been built. Once again, welcome to the world of science and space exploration. NASA scientists had been continuously working on this telescope for the past 3 to 4 years, and today it is known as the James Webb Space Telescope. Built at a cost of $10 billion, about 7.5 trillion rupees, this achievement is the result of the sweat and tireless efforts of thousands of engineers. It is the most powerful and most complex telescope ever built, capable of observing events that happened millions, even billions of years ago in the universe. That is why many scientists also call it a time machine. NASA now possesses a tool through which the hidden secrets of Earth and the universe are about to be revealed. But the question is, how can this telescope see events that occurred millions or billions of years ago? How does it work? And what all will we be able to see with it? To answer these questions, it is important to understand how we see things. When we enter a dark room, even though our eyes are open, we cannot see anything. But as soon as the light is turned on, everything becomes visible. This means that all the objects were already present in the room, but without light, we could not see them. When the light reflects off those objects, reaches our eyes, we begin to see. In other words, light is essential for seeing anything. Light travels at a speed of about 300,000 kilometers per second. Inside a small room, it spreads almost instantly. But when this same light travels across the vast universe, it obviously takes time to go from one place to another. The distance between the Earth and the Moon is about 384,000 kilometers. Sunlight reflects off the Moon and then reaches Earth, which is why we see the Moon. Light takes about 1.3 seconds to travel from the Moon to Earth. This means that the Moon we see is actually a version that is 1.3 seconds old. Now consider Saturn, which is much farther away. The distance between Earth and Saturn is about 1.6 billion kilometers. Light traveling at 300,000 kilometers per second takes about 5,333 seconds, or roughly 1.5 hours, to reach Earth from Saturn. This means that the Saturn we see from Earth is actually 1.5 hours old. Even if Saturn were to break apart at this very moment, we would still see it as normal for the next 1.5 hours. So it would not be wrong to say that we are looking into Saturn's past. That is why scientists and astronomers do not measure distances in space in kilometers, but in light years. The distance light travels in 1 hour is called a light hour, and the distance it travels in 1 year is called a light year. Since light takes 1.5 hours to reach Earth from Saturn, we can say that Saturn is 1.5 light hours away from Earth. Now let us move beyond our solar system. The universe is unimaginably vast. In this image, the galaxy you see is the Milky Way, and this tiny dot within it represents our solar system. The Milky Way galaxy is about 125,000 light years wide, meaning it would take light 125,000 years to travel from one end of the galaxy to the other. What is even more astonishing is that countless such galaxies exist in the universe. Our eyes cannot see them because they are so far away that their light is too faint for us to capture. To observe these galaxies and the planets within them, we use telescopes. Inside a telescope, there is a curved mirror that reflects even the faintest light toward a single focal point, multiplying it. The more light a telescope can collect, the more it can see into space. Launched in 1992, the Hubble Space Telescope can observe galaxies located several billion light years away from our solar system. One of its most famous images is known as the Deep Field, which shows galaxies as they were in the distant past so far back that Earth did not even exist at that time. The light from these galaxies was emitted around 10 billion years ago and is only reaching us now, while Earth itself formed about 4.5 billion years ago. So the question arises, if the Hubble telescope can already see so far into the past, why do we need the James Webb Space Telescope? Hubble has a mirror with a diameter of 2.4 meters, while James Webb has a much larger 6.5 meter mirror. Hubble can collect about 100 times more light than the human eye, whereas James Webb can collect 1 million times more light than the human eye. Engineers say that James Webb is so powerful that if it were placed on the moon, it could detect the light of a small candle on Earth. Not only that, the James Webb Space Telescope can also detect infrared light. According to science, the light from galaxies and stars that are moving away from us shifts into infrared wavelengths by the time it reaches Earth. Neither the human eye nor the Hubble telescope can detect this infrared light, but James Webb can. With its help, we will be able to discover celestial objects that exist in the universe but are invisible to us. The telescope has been designed in 18 segments so that it can fold up to fit inside a space shuttle. Once it reaches a specific location in space, its mirrors will unfold. Because James Webb observes infrared light, it must remain extremely cold. Its mirror side must be protected from even the slightest heat from the sun. That is why it always faces away from the sun. On its backside, it has a special 6-layer sunshield, which, when fully deployed, is as large as a tennis court. The entire system is so complex that even a tiny mistake during deployment in space could destroy billions of dollars and decades of hard work in a single moment. On December 25th, 2019, the James Webb Space Telescope was launched into space forever. It will be positioned about 1.5 million kilometers away from Earth at a location known as the L2 point. According to NASA's estimates, it will reach the L2 point by January 25th, 2014, and if everything goes according to plan, James Webb will begin its mission as soon as it arrives there. We hope you enjoyed this episode as well. Please like and share it generously. Thank you very much for your loving comments, and we will meet again in another amazing video.